Greetings everyone, welcome to our YouTube channel. In this video, we will cover the topic of limits. So limit processes are the basis of calculus. As opposed to algebra, where a variable is considered to have a fixed value, we allow a variable to change continuously and study how a function's value changes. Consider the function, for example, y is equal to 2x, okay? As x increases here, also y increases, right? As x approaches a number, let's say x approaches 100, y gets closer to the number 200, right? So limits are concerned with what the value of a function, in this case y, approaches as a variable. It is based on here, it's x, approaches a number, and in this case we say 100, right? So it's not the actual value of the function when the variable equals the number. So approaching, you will hear this word a lot when it comes to limits. Let's say on this number line, okay, we have 4 here, right? So when I say approaching, it's not very from far away, but very close. Let's say like from 4.5, from 4.2, okay, from 4.001. You see, they're very close. So as we get closer to 4 from the right side, from here, okay, so here values, they are greater than 4, we will show that this as 4 plus with plus sign, and this is the right hand limit approaching from the right. Okay, same logic. When we get closer 4 from the left side, let's say like from 3.5, like 3.99, okay, so we will show this as 4 and with minus sign as an exponent here. So these values are very, very close to 4. Okay, these signs, these negative and positive signs, they show if they are either approaching from left or right. So let's see let's see it with the function. For example, when we look at this graph, as you can see, we have here this f of x function, and as you can see on this graph, f4 is equal to 3, right? You can see this from this graph. So let's see if this function has a limit or not, okay? So we will first get closer to 4 from right side, okay? So how I write this? It's limit as x approaches 4 from the right, f of x is equal to. So when we look at this graph, as you can see, let's start from here. When we look at here, this point goes here, and then as I approach to 4, as you can see, also y line here approaches the value of 3, right? So so that's why I can say that limit as x approaches 4 from the right side, f of x is equal to 3, right? Because when I get closer to x from right, also my y values, it gets closer to 3. So let's look at from the left side. Limit as x approaches 4 from the left, f of x is equal to. So from here, as you can see, when I get closer to 4, when I approach to 4, also our y values, they're also getting closer to 3. So also our left hand limit is equal to 3. So when these two limits, when they are equal to each other, it means that the function has a limit and that is equal to 3. And I write this as limit as x approaches 4, f of x is equal to 3. Now let's see what happens when different values approach from left and right. So in this example, we have here one piecewise function, okay? So I am looking at its limit at 3. So when I approach 3 from right side, let's see what value y gets. So as I approach 3 from the right side, let's see, let's draw like this. So when I approach from the right, as you can see, our y value, it gets closer to 6, right? So I can say that limit as x approaches 3 from the right side, f of x is equal to 6. Okay, so let's look at the left side. So when I approach 3 from the left side, let's see what happens. So here, when I approach from here, as you can see, when I approach 3 from the left side, y gets closer to 4, right? As you can see, it gets closer to 4. So I can say that limit as x approaches 3 from the left side, f of x is equal to 4. Now, since these two limits, they are different, we say that limit doesn't exist, okay? So we write this as limit as x approaches 3, f of x does not exist. So all you need to do is to look its limit from right and left side. If they are equal to each other, we say yes, it has a limit. If they are not equal to each other, it means that the function does not have any limits. Now let's continue with polynomial functions. Let's see how we find their limits. So finding the limit of a polynomial is a simple process. The easiest method of taking the limit of a polynomial is substitution. The value of a polynomial as x approaches a is equal to f of a. For example, here we have limit as x approaches 3, x cubed plus 2x squared plus 7. So all you need to do is instead of x, you will write 3. So let's do that. It's equal to 3 cubed plus 2 times 3 squared plus 7, and this is equal to 27 plus 9, 18 plus 7 is equal to 52. Same logic here. Limit as x approaches 2x squared plus 3x plus 4, and all you need to do is to put 2 instead of x here. So it's 2 squared plus 3 times 2 plus 4. So this is 4 plus 6 plus 4, and this is all equal to 14. So we don't need to check the values when they approach from the right or left. That's why it's a very, very easy process. Limits of piecewise functions. So piecewise function is a function defined by multiple sub-functions, okay, and each sub-functions applying to a certain interval of the main function's domain. For example, here we have f of x as our main function, and we have here 4x minus 8 and 1 minus 2x as our sub-functions, okay. So when it comes to piecewise functions, you need to take limits from left and right side and check if these values are equal or not. It's same thing for when you have absolute values. So also here we need to take limits from left and right side. Why? Because the absolute value f of x is equal to f of x when f of x is greater than or equal to 0, right? And it is equal to minus f of x when f of x is less than or greater less than or equal to 0. So for these two functions, we need to take limits from both sides, from left and right side, and we will check if these values are equal or not. But when it comes to for polynomial functions, you just substitute that value. Okay, so let's do some examples for you to understand better. Let's look at this example. Here we have f of x is equal to x over 2 when 4 is less than x, and f of x is equal to 3x minus 10 when 4 is greater than or equal to x. So what's the value of limit as x approaches for f of x? So all you need to do is first you should check from the left and right side. Okay, let's do that. Limit as x approaches 4 from the right side, so it is x over 2. Why? Because as you can see, we are looking the values where x is greater than 4. So here, as you can see, 4 is less than x, which means x is greater than 4, right? That's why we take this function. So it is limit as x approaches 4 from the right side is x over 2 is equal to, all you need to do is here, instead of x, you will put 4, so it is 4 over 2, and this is equal to 2. Okay, so let's look at from the left side. Limit as x approaches 4 from the left, which function we will take? As you can see here, x is less than 4, right? That's why we take this function. So it is equal to 3x minus 10. So here it's 3 times 4 minus 10. So this is 12 minus 10, and this is equal to 2. So as you can see, since these are equal to each other, we can say that this piecewise function has a limit at point of 4, and that is equal to 2. So we write this as limit as x approaches 4, f of x is equal to 2. Let's look at these examples. In the first example, we have f of x is equal to x squared minus 4 when 1 is less than x, and x plus 2, f of x is equal to x plus 2 when 1 is greater than or equal to x. So does limit x as x approaches 1, f of x exist? So all we need to do is to check from the left and right side, right? So let's do that. Limit as x approaches 1 from the right side, f of x. Okay, so which function I will use for this one? We will look for the values greater than 1, right? Which is here, this one, x squared minus 4. So this is x squared minus 4, our function. So when I put 1 instead of x, this is equal to 1 minus 4, and this is equal to minus 3. So let's look at from the left side. Its limit as x approaches 1 from the left side, f of x. Which function we will use? This one, right? Because here we have our x is less than 1. So it will be x plus 2. So instead of x, I will write 1. So it's 1 plus 2, which is equal to 3. So as you can see, from right side we found minus 3, from left side we found 3. So since these are not equal to each other, we say that limit as x approaches 1, f of x does not exist. Okay, so let's look at the second example. Here we have limit as x approaches 0 from the left, the absolute value of 2x over x. So here we have this absolute value, right? We should get rid of this absolute value. So here it says that x approaches 0 from the left. When you look at this on number line, okay, on the number line, 0 is here. So when you get closer to 0 from the left side, it means that these values, they are negative, right? So it means that this 2x goes, the absolute value of 2x goes out as minus 2x. So it is minus 2x over x. Okay, so we can simplify these x's and our solution will be minus 2. Don't put 0 instead of x here immediately. First, always try to do simplification, and after that you can put that value instead of x. But now here for example, since we can do this simplification, we can do just this simplification, and we will get the value of minus 2 as our answer. In this example, we have limit as x approaches 3, the absolute value x minus 3 over 3 minus x. So same thing, we should approach from both sides. Okay, let's do that. First, which value here, which value of x makes this absolute value 0? It is 3, right? So limit as x approaches 3 from the right side. So let's see how this absolute value, how it will become. So when I put this 3 on my number line, okay, so when x is greater than 3, which means when we get closer to 3 from right side, okay, as you can see, these values make this absolute value positive. Okay, also it means that we approach x we approach 3 from the right side. So since these values makes this absolute value positive, this absolute value goes out as x minus 3 over 3 minus x. Okay, since these values makes this absolute value positive. So let's continue here. What we can do, a limit as x approaches 3 from the right side, x minus 3 over, instead of 3 minus x, I can write this as x parentheses of x minus 3 is the same thing. And now I can do simplification when I can cancel these out, and then from here we will get minus 1. As you can see, first you should simplify, and after that substitute that value. Okay, so let's look at from the left side. Limit as x approaches 3 from the left side. Okay, let's see what happens to our absolute value. So when you get closer to 3 from the left side, these values make this absolute value negative, right? Let's say you put 2 here. It's 2 minus 3, it's minus 1, right? So this absolute value goes out as minus x plus 3, okay, over 3 minus x. These are same thing, so this is equal to 1. So as you can see, from right side we got minus 1, from left side we got 1. So we can say that limit as x approaches 3, the absolute value x minus 3 over 3 minus x doesn't exist. In this example, we have f of x is equal to x minus 3 when x is less than 4, f of x is equal to 2 when x is equal to 4, and f of x is equal to bx minus 7 when x is greater than 4. If this function has a limit at the point when x is equal to 4, what is the value of b? So if this function has a limit at the point of 4, it means that it is limit from the left and right side, they are equal to each other, right? So let's find their values. So when limit as x approaches 4 from the right side, it means that I will look at the values greater than 4, which is this function, right? So I will use bx minus 7 here. So it is, instead of here we have bx minus 7, okay, it's equal to, so we put 4 instead of x, so it's equal to 4b minus 7. So let's look at from the left side. So we will look at the values less than 4. In this case we will use this function, right? X minus 3. So instead of 4 I will put instead of x I will put 4. So this is 4 minus 3, and this is equal to 1. So as I said before, these two has to be equal to each other in order to have a limit at this point. Okay, so let's make this equal to each other. So 4b minus 7 is equal to 1. So from here 4b is equal to 8 and b is equal to 2. Now let's see properties of limits. So the limit of a constant function is the constant. As you can see here, limit as x approaches a of constant is equal to constant. Let's say you have limit as x approaches 4 of 8. Okay, so this is equal to 8. It doesn't matter where x approaches, it will be always 8. Okay, so here we have some rule. This rule states that the limit of the sum of two functions is equal to the sum of their limits. So limit as x approaches a in the parentheses of f of x plus gx is equal to limit as x approaches a f of x plus limit as x approaches a of gx. Okay, so here we have, it's the same for the product rule. This rule says that the limit of the product of two functions is the product of their limits. So here we have limit as x approaches a in the parentheses of f of x times gx is equal to limit as x approaches a f of x times limit as x approaches a of g of x. So here we have constant multiple rule. So the limit of a constant times a function is equal to the product of the constant and the limit of the function. Okay, so you can write this constant out of this limit. So in this one, this is absolute value rule. So the limit of an absolute value of f of x is equal to the absolute value of the limit of f of x.